The 1.6 is a pretty silly section, but I put it in, so I'll chat about it. Absolute value functions, we already know what they look like. You guys have told me this. The parent graph is that V-shaped graph where there's two different line segments connected at the origin. One of the line segments is just the y is equal to x line. The other line segment is y is equal to negative x. And this makes sense because when we look at all of the positive inputs for x, they pop out themselves. So it makes sense that y is equal to x. And when we look at all the negative inputs, they pop out the opposite of themselves, the additive opposite, so negative x. If we wanted to, we could even go so far as to redefine this beautiful function as a piecewise function, where it's equal to x as long as our x is positive, and it's equal to negative x whenever our x is not positive. So that's the way to make our absolute value function a little more mathy in terms of what's happening. Another way that you'll see the absolute value function used in mathematics is to talk about distance away, especially absolute value equations, distance away from zero. So in general, you can think of an absolute value, if we're just talking about the basic absolute value x is the distance of x, not to confuse with a point on this coordinate plane, of x from 0. Now, if we change this up and we add some of our shifts and other pieces, think about what happens here. So if we add now x minus 2, well, it's no longer about distance from 0 because we've taken this graph, we've shifted it 2 to the right, and so we now have this absolute value function with a shift. So x minus 2 is actually going to be the distance of x from 2. And you can plug in some numbers to see how that makes sense. If x is equal to 5, then 5 minus 2, absolute value is 3, and 5 is 3 away from 2. If we looked at negative 1 minus a negative 2 is also 3, and so in the absolute value sense. So both of those are 3 away from 2. So we actually use this notation quite a bit when we get into like a Calc 2 and we start talking about intervals of convergence for our power series. But that's where this really becomes useful later on, is it's shorthand for saying, hey, I want this to be true. So if you were solving out the actual equation, x minus 2 is absolute value is equal to 3, this is going to give you out both of those solutions. It's basically asking in words what distances, what x's, what values are distance of 3, because, right, this is equal to the distance away from 2. 2. And so you could start with your number line of 2, and then you go 1, 2, 3. I'm over here at 5, 1, 2, 3. I'm over here at negative 1. Those are my two solutions to this particular absolute value equation. Now, typically, we've learned absolute value equations in a more algorithmic way. So let's look at this, how we would do the algorithm for this in, say, an algebra class. So if we had the absolute value of x minus 2 is equal to 3, typically in an algebra class, we'd say, well, the absolute value, it has two different pieces to it, right? It's that piecewise function behind the scenes. So either x minus 2 is equal to 3, if we look at the inside, or that inside piece was equal to negative 3, right? Because if we got out a negative 3 as the argument in the absolute value function, it would give us 3. If we got out a positive 3, it would give us 3. And then we'd go forth and we'd solve both of these equations separately. And we would say that x is equal to one of these two values. X is either equal to 5 or x is equal to negative 1. All right. And if things get a little more complicated, hopefully you remember something like the absolute value of x minus 2 plus 5 is equal to, let's do 9. You hopefully remember that in anything like this, before we start going into our algorithmic, how do we get rid of an absolute value sign, we've got to isolate the absolute value first. So in a question like this, you'd want to subtract the 5 first. Sorry, my cat's clawing something. And then you could solve this problem just like the last one. So you can also, of course, think about what this looks like graphically, right? What's happening with my absolute value function that's behind the scenes here? Whenever you're solving an equation, you're looking at setting two functions equal to each other. You're finding those intercepts. So this is an absolute value, we know that, with a shift to the right, 2, and up, 5. All right, so 1, 2, 1, 2, 3, 4, 5, and we would draw our acute absolute value function. Floop, floop. The other side of this equation is just 9. Well, y is equal to 9. 1, 2, 3, 4, somewhere up here. And so what you're finding when you find the solutions to this is you're finding the x's that make these two functions equal to each other. So that's another way to handle this. In fact, let me pull up Desmos real quick. Oh, I didn't plug in my thing, so I have to use the actual built-in keyboard. Desmos.com. Let's go to the graphing calculator. Let me make sure that we're good in terms of my view.